Iterators and generators are crucial for efficient data processing in Python. The iter function returns an iterator from an iterable, while next retrieves the next item. Mastering these functions enhances control flow, allowing for seamless data handling in applications. Understanding their mechanics is essential for optimizing performance and resource management. Iteration in Python is essential for processing data efficiently. It allows developers to execute operations on each element of a collection, such as lists, tuples, or dictionaries, using the for loop construct. This mechanism simplifies complex data traversal, enabling systematic navigation through data structures while abstracting the underlying complexity. Iteration is the core process of executing code repeatedly over sequences or collections, crucial for data processing in Python. It efficiently traverses data structures like lists, tuples, and dictionaries using the for loop. This mechanism allows sequential processing and systematic navigation through complex collections, with Python's syntax abstracting the underlying complexity. Understanding the distinction between iterables and iterators is crucial in Python. Iterables, like lists and strings, can be looped over multiple times and must implement iter. Iterators, however, produce items sequentially, are exhausted after one iteration, and must implement both iter and next. Every iterator is an iterable, but not vice versa. Python's iteration protocol begins with the for loop calling iter on an iterable, triggering iter to return an iterator. The iterator's next method fetches items sequentially, maintaining state. When items are exhausted, next raises stop iteration, ending the loop. This process mirrors manual iteration using iter and next. The Python iteration protocol begins with an iterable object, such as a list or string. The iter function is called, invoking the iter method to create an iterator object. This iterator, equipped with the next open parenthesis, close parenthesis method, retrieves items sequentially. When all items are accessed, a stop iteration exception is raised, signaling the end of iteration. The iter function is pivotal in Python's iteration protocol, transforming iterable objects into iterators. It accepts one or two arguments, enabling advanced iteration patterns. With a single argument, it returns an iterator. With two, it repeatedly calls a function until a sentinel value is reached. This function is essential for explicit iteration control. The iter function is crucial in Python's iteration protocol, converting iterables into iterators. It accepts one or two arguments, a single iterable, or a function with a sentinel value. This enables manual iteration control and custom patterns. For example, iter open parenthesis, 1, 2, 3 close parenthesis creates an iterator from a list, while iter open parenthesis file.readline, close parenthesis reads lines until end of file. The next function retrieves the next item from an iterator, calling its next method. It maintains the iterator's state, ensuring sequential access. When items are exhausted, it raises stop iteration, unless a default value is provided. This allows for custom iteration logic, enhancing control over sequence traversal. Explore practical applications of iter and next for manual iteration control, exception handling, and advanced patterns. Use iter to create iterators and next for manual traversal. Handle stop iteration with default values for safe iteration. Implement two-argument iter with sentinel values for efficient data processing, maintaining O1 time complexity per element access.